Adding in the keyboard requires us to just do a little bit of extra work. So what we need to do is we need to track on the computer when we have pressed a key and when we have released a key, and then we just need to figure out what is the key that we pressed and what is the key that we released. And the good part about that is all of the keys on the keyboard have a number associated with them. So because the keys are tied to a number, we can say, hey, is the number code of the key that was pressed or released a certain number? And if the answer is yes, then we can make something happen. And that's the long and the short of doing it. So to make that happen, we end up requiring two more functions inside our main file. And technically what we could do is we could put it directly in our draw. We could say, hey, if the key pressed is this. But the problem is if we put it in the draw, we end up seeing our movement happen based on the key repeat rate setting for the keyboard. So in your system preferences on a computer, you're able to say, I want my key repeat rate to be fast or slow or medium. And if that's what you're using to kind of control the movement of things on screen, you get some really weird results where it might start out slow because the computer always waits. You press a key, it waits a little bit to go, well, maybe you just have heavy fingers. So I'll wait a little bit, and then I'll start repeating. And if we move based on that, we end up pressing the key and it kind of goes chunk, 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 chunk. And it's not a good way of working. So we're going to take advantage of the fact that we have key pressed and key released methods available to us. Now these are much like we have mouse methods, we have keyboard methods that we can work with on it. Now to do this, what we want to do is we want to just find out, hey, if I press a key, is it the key I pressed? And when I release a key, is it that key that, we check and say, hey, if the key released was one of the keys we look for, then it will respond appropriately. Now, within kind of interactive visual and game programming, what we typically do inside these key pressed functions is we then set a value equal to true or false. And we associate that value with, say, a directional movement, left, right, up, or down. Then we may have things like fire, shields, or whatever extra features you want to build into your project. So we're going to start out first with left on here. And we're not going to worry about the key code of it. We're just going to worry about when I press left, but it'll just be any key, then my player's going to start going. When I release any key, it's going to stop moving. So we're first going to just start with that. But actually, based on my artwork, maybe I'll go with right. So I'm going to say when I press a key, I want right to be equal to true. And then when I release a key, right is now equal to false. Now, those of you who are paying attention, you will realize that I have not defined right. I have not given it a value yet, so we probably need to do that. And seeing that it has values of true or false means that right is a particular type of data, and it is a Boolean. Now, when we are using values like this, it probably is going to make sense to do something like start it as a false value. So right now, when I press a key, right will be made true. When I release any key, theoretically the key that I just pressed, right will become false again. So press, release. Now, knowing that, we're going to go into our player class and modify that a little bit. So player is no longer moving based on the mouse. We're going to make player adjust X and Y based on whether these values are true or false. So what we can do within that is comment these lines out, because we're not going to need those any longer. And we're going to modify it a little bit and just simply do if right is true. And this is a double equal sign because we're asking the question, we're not assigning the value. We're not saying right is true, we're saying, hey, is right true? So we use the two equal signs. So if right is true, then we want something to happen. Now, I want to move to the right. So that means I am adding to my X position. So what I will do is say speed X is now equal to 5. That's just, a random number I pulled out. It's a decent amount to move per frame. So we'll say speed X is equal to 5. This now means when right becomes true, speed X is equal to 5. I'm not updating X yet, so we probably will want to put that in and say X plus equals speed X. Now I'm not saying X plus equals 5 here, because if I press the left key, we're probably going to set speed X equal to a negative amount, such as -5, so then it goes in the opposite direction. But as always, and I'll just get rid of these, we don't need those anymore. But as always, it's always a really good idea to start with as simple as it can be, and then we add more. That's why I didn't program out and make left, right, up, down, and do. We're just starting out with one direction. Get one direction working. Once we prove we can make one work, then we work on the others, and then if we encounter additional conflicts or difficulties, we figure out how to solve those at that point. So we want to always try and keep it as easy as we can, as long as we can. Now, let's run it and see. Okay, it's there. Now I can press the right key and notice that it took off and it didn't stop and it kept going. So we know that I can press a key and it moves. But what I need to do something is we need to now kill it. So if right is equal to false, speed X needs to be equal to 0. So now when I run it, press the key, let's go. Now I can press any key to make this happen, but I currently only have the ability to go in one direction. But seeing how this is starting to work for moving one way, now we will want to figure out how can we get it moving in the other direction. With the plane moving off to the side, we need to narrow down our actual key codes that we're working with here and figure out how to grab those. So it turns out on our keyboard, the numbers associated with the arrow keys start out with the left arrow is equal to 38, the right arrow is equal, or 37, because we go in a circle clockwise starting with the left arrow. 37, then up is 38, right is 39, down is 40. So 37, 38, 39, and 40 are always the 4 arrow keys. The easiest one to remember is down is 40 and then go backwards from there. So I always know that if I'm screwing it up when down didn't come out as 40. Then I'm like, oops, I messed that one up. If you want to learn or know any of the other keys, you can look up ASCII, ASCII, character codes, and you will find these key codes, just a simple Google search, and you'll find hundreds of pages that show you these Wikipedia pages, other reference pages, that all the key codes are out there that correspond to your keyboard. We also have character codes, so we can find out even is it an uppercase or lowercase letter. So we can be that granular or specific if we so choose. So it's possible to be that detailed, but for right now, we just know that we want 37, 38, 39, and 40. Those are the 4 numbers that we're working with there. So I'll just leave those out for now. So what this requires me to do is we'll make right work, and then once we know we're right, then we will work on adding in the other characters there. So we can say if our key code is equal to, and right would be 39, then we will say right is equal to true. And we can put it into our released. If the key code is 39, right is equal to false. So if I press an up key, nothing, left key, right key, and when I press and release the right key, we can see it is indeed working. But now no other key on the keyboard registers or shows as part of that. Now adding in a left. So right, left. It's a good idea to put comments in as you're working with this as well. If you need to remember what the key code numbers are, that's useful. So I'm going to have left before right because that will make me happier going in that road. One of the problems that we're encountering now is when we run your project, it will go in one direction, but it won't go in the other, even though you told it to. If we look at what's happening, it says, hey, if left is true, do this. Then it says if right is true, do that. Okay, that's good. But then it says, oh, hey, if left is false, kill the speed, or if right is false. So what we're running into is, even though we said, hey, go ahead and make it go in that direction, it's being killed by one of these two statements. So it's not working quite right. And the way that we can fix that is by combining them. So what we're able to say is if left is false and if right is false, kill the speed. So we say, hey, if left is true, speed is minus. If right is true, speed is plus. But if they're both false, kill it. So now, if I run my project, I can go left, I can go right, and it's getting now much closer. So it's getting much closer to wanting to behave, but it's not all the way there yet. So what we're trying to do is to take into account that because when we say when the left is true, make it go one way. When right is true, go the other way. But we could wrap it into an else statement. So if left is true, else if right is true, else speed is 0. And then that would work until I press 2 keys, and then the second in that, the else one in that if statement would actually always dominate. And we're going to prevent that from happening by adding an else down here. So if we watch it now, so after fixing it, my double rights on the release, so my left can actually let go so it works properly. We set the speed, then we set the next speed based on left or right when it's true. But when they're both false, we want it to go to 0 because our possibilities are one is true, the other is true, they're both true, or they're both false. Those are the only combinations that I can really have when I'm asking about my left arrow or right arrow. Either neither one is being pressed down, both are being pressed down, or one is being pressed down or the other is being pressed down. Those are my only 4 possible situations that I can have. So when the left one is being pressed down, make it go that way. When the right one is being pressed down, go that way. If I haven't pressed either one down, we don't want to go anywhere. And if I've pressed both of them down, I don't want to go anywhere. Because I don't want one to take precedence over the other. Left is not more important than right, even if you're left-handed. So to that end, knowing that those are the only 4 possible scenarios I'm facing. One is down, the other is down, both is down, neither is down. So that's what my 4 statements here are taken into account. Now we separate it like this into a standalone if, a standalone if, so that I want this if to be by itself, because now besides left, right, I will also be adding an up and down, which will be opposing, so they'll look just like this. But I may also have additional keys that I program into my project. So if I did these 4 as if, else if, else if, else if, then I wouldn't be able to get the keys to play quite as nice with other key combinations. So that's why we separate each of the individual key possibilities into their own if. But we take care of when they need to counteract each other by both being down or both not being down, then we put that into this chunk here. So that's the theory and rationale between using all four of them. So now I can go left, I can go right. But if I press both, nothing happens. And when I'm not pressing either one, nothing happens. So that is how to go left and right. Now I'm going to challenge you to make yours go up and down. So adding in the up and down, add in the Booleans, give them their default values, put in the key pressed, put in the key released, and then move vertical. And moving vertical, and then I moved the speed X down below that, so it just kind of looks a little bit better when you have all of your conditionals that figure out how to adjust speed X, and then you actually modify X and Y by speed X and speed Y. And now my sprite is able to move. The next thing that we want to do is we want to be able to rotate this. So I want to rotate my artwork based on pressing the keys. So to do this, we can use our rotate function that's built in. But we have to know how much to rotate it. And that's where we're going to put that into when I press left and it's true, we'll specify what we want it rotated to. Now we're not doing a gradual rotate because that would require us to then calculate moving on an angle. Moving on an angle requires us to use a couple extra math functions. We have to use the sine and cosine values so that we can figure out how to move on an angle. So we have to know how much I've rotated, and then we calculate my change in x and my change in y with sines and cosines. It's straightforward formulas that other people have written. We just plug them in and go with it. We'll look at that in coming weeks. But right now we're just going to make it, if I press up, it rotates to be pointing up. If I press down, it rotates to be pointing down, left and right respectively. So I need to store a value. I'll just add it on its own line. And I'll just give it a real pleasant sounding name like rotate amount, so that I know what it is. I can say rotate amount in the beginning will be 0. Now, if I press left, that means I'm going to rotate 180 degrees. Remembering that we're always pointing horizontally out to the right, that is 0. So when we're moving to the right, our rotate amount is indeed 0. Now, one thing to remember is that most programming languages, when they're dealing with rotational values, they don't use degrees, but they actually use radians. So we will have to do a conversion. And the good part is processing has a really easy function of radians that you just say radians, parentheses, and you put the degree amount you want and it converts it. So it's really friendly to use that way. But if I'm going left, my rotate amount is going to be at that point 180 degrees. So I've now rotated halfway around that circle. Now we could do our degree conversions here if we wanted, but I'm just going to leave them plain, and then it's only when we issue our rotate command will we actually then specify that. So now when I go up, that means I am going to be rotating in one of two possible ways. Recognizing that from horizontal, if I want to be pointing straight up in the air, that's actually going to be 270 degrees because we start out horizontally to the right, and it would be clockwise. That is a rotational value, so I can either say 270, or I could go in a counterclockwise direction, a negative value, and say minus 90. And that would be equally as useful. It would give me pretty much the same result. So I could say 270, or I could say, if I wanted minus 90, would be an acceptable value there. We point down, our rotate amount is going to be 90 degrees. So we've now calculated how I want it to rotate and to appear on screen. And then what I can do is I can even issue a command, and I can say rotate Now I can tell it to rotate, but again, because it wants that to be in radians, what we need to do is do a conversion. And the way that we do it is we just take that value, put it in parentheses, and put the word radians in front of it, and it will do the math for us. Otherwise, we can take our rotational amount and we can multiply it by 2 pi and divide it by 108, or multiply it by pi divided by 180, or I don't know. I'd have to go refresh the formula, but it's multiplying by pi, dividing by 180, and 2 pi divided by 180. So we could do that, or we can just say radians, which is easier. So now if I run this and get no error messages, I say yay. And the moment I go right, it works. But if I rotate left, it disappears. If I rotate down, it goes away right. Yeah. So it's not working terribly well yet, because I'm rotating around my top left corner and it's going off screen. So what we have to do is we have to now translate to our X and Y positions. So we're going to move the registration point to X and Y. But when I draw my player, I'm going to just get rid of that stuff there for a moment. We're going to draw it at 0, 0. For now, and then we'll update that in a moment. So now we can see it's rotating around its own top left corner. So we have to take that X and Y value, which is where the artwork is, and shift the painting of the artwork, because the X and Y is its X and Y. That is the X and Y of this object, but we need to move its artwork over a little bit. And we can move it over a little bit. Sorry, wrong keys. We can move it over a little bit by saying, well, why don't we just go, we'll move it over half of our width, and we'll move it over half of our height. So again, reusing those values that I had left there. Now when I rotate, now if the artwork was perfectly centered on itself, then the plane would do a perfect flip. But we can see it's because of the shadow. So this artwork with the shadow, I would almost want to have even 4 separate pieces of artwork. Maybe not even rotate, just show different artwork based on the different angles so the shadow always remained consistent. But now I have artwork going around on screen. Now an additional possibility would be you could rotate 45 degrees and have your artwork then rotate 45 degrees, and you could be listening for, well, what happens when up and right are pressed? Then you rotate 45 degrees, negative 45 degrees. When down and right are pressed, you rotate positive 45. So you work out the degree amounts, and then you could actually be pointing in, when you press 2 keys, pointing in those angles as well. All right, so I have added an additional rectangle and ellipse to my project here. Now, if I run this, we'll see, wait, that rectangle is supposed to be at 100 by 100. But if we notice, it's about, 100 pixels over and 100 pixels down from the center of the airplane. And when I rotate the airplane, oh, yeah, there's some problems going on here. Those objects are being affected by this translate and rotate. Now, if I move the player down, so that it's the last thing in my draw function. Now when I go, they're not being affected. So what happens is once you translate, it stays translated until you get to the end of your draw function. And then translate, rotate, all of those transformative effects are reset. So it's as if they never happened. Then the next frame they happen again. So if I draw a bunch of things and then do translates and rotates and other stuff like that, no harm, no foul. But if I'm going to do my translates and rotates and then draw something, that translate and rotate is going to continue to affect what's there. But there is an easy fix. And that fix is where I say something along the lines of push matrix. And when I'm done with my effect, I say pop matrix. So what happens here when I say push and pop matrix? Whoop, wrong keys. There we go. Push matrix says, all right, store whatever the current transformation state of my project is. So it holds that in memory. Then it allows me to translate, rotate, move, do whatever, all my different things. And then when I say pop matrix, it says, okay, forget all that stuff I just did. Go back to how the world was when you said push matrix. So this means when I do this, I can now have each object individually moving around on screen without it affecting anything else. So if every object that's being told to display does a push matrix, does all of its rotates and translates and whatever gobbledygook it wants to do, and then we say pop matrix to say, okay, go back to how you were before we started doing that, then objects act independently and don't mess each other up. So now we can see that my airplane is not affecting these objects, even though the objects come after them inside my draw function.